Right, so I'm going to talk about how you can write Excel add-ins in D. Don't ask me why, it's just because people need it. This work was supported by and financed by Symmetric and Kaleidic, and let's go. Right, so Excel add-ins. Excel allows users to call code written by them from a spreadsheet itself, so you don't need to leave Excel. You're doing some work in a formula in a cell, you can type equals your function, and you can call stuff in. They can do anything, go over the network, do crazy stuff, calculate whatever you want. What you have to do is you have to compile a DLL, and then the Excel add-in manager, you go into it and you activate it, and now you can call your own functions. Normally this is done in C++, as you can imagine. The XSL, which is just another name for DLL, I guess for marketing reasons, exports a few number of functions. Exports is more than just what DLLs usually do, which we'll see in a bit. And then you can just call it, like I said, with typing equals myfunc and passing some parameters to it, and then you can go nuts. Right, so what do you need from an XSL? What are its duties so you can call it? DLL main, because it's a DLL, so nothing to say there. Then Excel auto open and Excel auto close do what you expect. When Excel loads the DLL, it calls the one, and then when it unloads, it calls the other. There's some optional functions as well for memory management and other things. And the actual code needs to be made callable. So first of all, your functions have to be declspec DLL export, which in D terms just means extern windows. The functions also have to be registered. This is the fun part. This happens at runtime. So in Excel open, you have to call into an Excel API and register your functions. They don't just need to be exported from a DLL like normal. No, you need to call some APIs there at runtime when it gets loaded. And so that's what happens. You also need a def file. Don't ask me why. If you load the DLL yourself, you can call the functions, but Excel appears not to be able to. So there's a detour here because Excel uses a variant type called Excel upper 12. I'm not going to say too much about it because I don't have a lot of time, but basically you can represent a double, a string, an array of things, a reference to another cell, all sorts of things. In practice, that's the only type that matters. In practice also, basically any code you write for Excel takes a pointer to one of these and returns a pointer to one of those. Now, if it's a pointer, where'd you get the memory from? Fun times. Yeah. So this is how the function registration I talked about looks like in C++. That's one function that you wrote. Now, notice how the name of the function shows up twice, actually 3 times if you consider the declaration of this function itself, and since this is C++, maybe 4 times because it's a header and a source file. Fun. Also, the third thing you see there, that UU, that's the type signature. Yes, you use strings for the type signature. That means it returns an Excel upper and takes an Excel upper, which is basically what you always see, but you can have multiple of those because you can have more than one argument. And then a bunch of other things that show up in the wizard that you don't really get to see in real life, but that's just one function. So the actual example code from the SDK has an array of these things, right, with the right number of columns and just the right number of functions, and manually you go into each one of these, tell Excel what the return types are, what the argument types are, what the function name is, and righto. Disadvantages, a lot of boilerplate, obviously. Error-prone function registration. You screwed up, haha, you crashed. Manual memory management, super fun. Can we do better? It's DConf, I'm up here, what do you think? This is all the code you need to write to register that function right now in D.
You got to go back slide.
Oh, sorry. That's a problem with not seeing what I'm doing. Anyway, this is all the function you need to write to register function calls in D. There's a main, which is just there to compile things. You import, you go, please wrap my modules. In that case there, you only see functions, but that's variadic, so you can tell it any number of modules. You just pass the name of the modules. Why strings? Because I don't want to import them first, and I'm lazy. Then in functions.d, you have a function there. It gets automatically wrapped. You do nothing. Now, realize that the function takes a double, returns a double and takes an array of doubles. Those are not Excel uppers. Excel does not know what to do with that. Not a problem. The wrapping code knows that, does compile time reflection, figures out what to do, automatically converts everything, handles memory allocation for you. You do nothing. It just works. And then you go equals doubles length, and that works. If your function happens to be an OGC, the wrapper function will also be an OGC. If you happen to allocate memory, well, oh wait, I was going to get to that. How do we do this? Well, compile time reflection, like I said. You can do this in Python. There's a library to do it, but it's at runtime. As far as I know, D is the only language that's statically typed that can do this sort of thing with no boilerplate. You write nothing. we handle it for you. Excel really calls this function, which is written for you using string mixins. Yep, I'm nearly out of time. So this is basically what happens. It imports your module, calls your function, auto-converts everything, and then returns. And if you happen to need to allocate memory because you want to return a string to Excel, where'd you get the memory from? Well, you can do this. You can do whatever you want to allocate memory. You put a UDA on your function called dispose, and Excel will call this after it's done with the invocation. And that's it. No boilerplate, just easy. I'll take questions while I guess he sets up.
Any questions from the audience?
Can we give Átila another round of applause for the fastest lightning talk I think I've ever seen?